guys, happy Wednesday. Go ahead and get out your math notebooks. Label it at the top. Today is December 16th. And we are going to go ahead and be taking a look at adding and subtracting fractions with unlike denominators. So yesterday we were adding and subtracting with like denominators. What does that mean, like denominators? Mimi? It's the same. They have the same denominators. So did we have to change anything with those denominators? No. Okay? But today they're going to be unlike denominators, meaning they are going to be having different denominators. And we cannot have that when adding and subtracting fractions. So we're going to have to be changing those denominators to make them like. All right? I have a math antics video for you first to watch. Please, please, please be watching carefully, guys. Okay? This is going to be, I'm not going to lie, this is going to be tough, but nothing that you can't do. Okay? What's going to make the difference in you struggling on this or you succeeding on this is how much effort you put into it. Okay? While you're watching this video, you should have no distractions. Pencils should be down. Okay? iPads are closed for my friends. Mrs. Long's class, my e-learners, if you're watching on your iPad, that's good. But don't be doing anything else. Okay? Don't be thinking about other things. Okay? We have your whole attention on watching this and then doing our practice with us. Okay? If you guys can do that, you guys will be successful at this. Okay? I know you guys can do it. All right, lights, please.
In this video, we're going to learn the basics about how to add fractions. Now, a lot of math books will teach you how to add fractions before they teach you how to multiply them. But here at Math Antics, we think you should learn the other way around. You remember how easy it is to multiply fractions, right? You just multiply the top numbers together.
We've not done that yet, so that's okay.
Together, and you have your answer. So you might be wondering, well, can't we just do that with addition too? Can't we just add the top numbers together and add the bottom numbers together and get our answer? Well, all right, let's try it and see, but I got a bad feeling about this. Let's try adding 1/2 to 1/2. So if we added the top numbers, we'd get 2, and if we added the bottom numbers, we'd get 4. But, well, that can't be right, because 2 over 4 simplifies to 1/2. And if you add 1/2 and 1/2, you should get a whole, not a half. Uh-oh, we must have broke some sort of math rule. I'm out of here. Okay, here's what we did wrong. It turns out that there's some important math rules called order of operations that say you have to do multiplication and division before you do addition and subtraction. Now, because fractions are just division problems, if you just added the top numbers and added the bottom numbers, you'd be breaking those rules because you would be doing the addition before the division. So, what are we going to do instead? Well, fortunately, there's a trick that lets us work around the order of operation rules and add fractions without dividing. But there's a catch. It only works for fractions that have the same bottom numbers. The trick is, if fractions have the same bottom numbers, we can add them by just adding the top numbers together and keeping the same bottom number in our answer. For example, to add 1/2 and 1/2, we just add the top numbers, and 1 plus 1 gives us 2. But we don't add the bottom numbers. We just use the same bottom number in the answer, which is 2. So 2 over 2 is a whole fraction. And that makes sense, because if you add 1/2 and 1/2, you get a whole. Let's see a few more examples. Like this one, 5 over 16 plus 2 over 16. Again, since the bottom numbers are the same, it's easy to add these fractions. All we do is add the top numbers together. 5 plus 2 equals 7, and that's the top number of our answer. Then we just keep 16 as the bottom number of our answer. So 5 over 16 plus 2 over 16 equals 7 over 16. Pretty easy, huh? But what about subtracting fractions? Does that work the same way? Yep, if the bottom numbers are the same, all you have to do is subtract the top numbers and keep the same bottom number in your answer. Here's an example of subtracting fractions with the same bottom numbers. 5 over 9 minus 2 over 9. First we subtract the top numbers. 5 minus 2 equals 3. Then we just write the same bottom number in our answer, 9. So 5 over 9 minus 2 over 9 is 3 over 9. Yep, Adding and subtracting fractions with the same bottom numbers is easy, and there's a special name for problems like this. It's called adding or subtracting like fractions. A teacher once told me that they're called like fractions because the bottom numbers are the same, or alike, but I think it's because they secretly like each other. Just kidding. But seriously, like fractions are easy to add with the trick we just learned. But what happens if you want to add two unlike fractions? What do you do if you have fractions with different bottom numbers? Unfortunately, the only way we can add unlike fractions without doing the division first is to change them so that they do have the same bottom numbers. In other words, we need to change our unlike fractions into like fractions so we can just use our trick. In math language, that's called finding a common denominator. Now remember that a denominator is just a fancy math word for the bottom number of a fraction. And common just means that they're the same. So, how do we find a common denominator so that we can add or subtract unlike fractions? That's what we're going to learn in the next video.
Lines, please. Actually, turn my left one off so I can see this a little better. All right, so yesterday we had taken a look at our Math Antics video. We did a kind of a preview of finding our LCD, our least common denominator. And then I have this help sheet here for you that you guys need to save on your iPads. This is going to be our process that we are going to follow today when we have those unlike denominators. Okay? So it says adding and subtracting fractions with unlike denominators. Okay? Common denominator method. That's what we're going to be following right here. And notice at the top, this little star, this little asterisk. Always reduce if you can. Okay? Reduce meaning, what's our other word we use for reduce? Mason? Huh? Not necessarily divide. Simplify. Simplify is that word here that we use also for reduce. Okay? So step one is that we're going to set up fractions vertically, meaning up and down. Okay? So they have 1/2 plus 2/3 as our example here. Step two is we are going to list the multiples of both denominators. And we've been practicing that. We've been listing multiples. So for 2, they made a list, 2, 4, 6, 8. For 3, they made a list, 3, 6, 9. Well, what's the smallest one that they had in common? Now, LCM, least common multiple, they circled was 6. Okay? So 6 is what we're going to then use then as a common denominator because right now they have a 2 and they have a 3. So we need to change that to a 6. So here they're going to have a 6 and a 6 as a denominator. But you can't just change the denominator like that without having an extra step in there. So step 3 is how we're going to make this 2 and 3 a 6. We're going to multiply our original denominators by a number that will give you your new denominator, okay? And I like the example they use here. They say that the jealous sibling. So whatever you give to the bottom, you have to give to the top. So to make this 2 a 6, what could I multiply? 2 times what would be 6? Hannah? 2 times 3, okay? So here they multiplied 2 times 3 to make it a 6. But jealous sibling, this one's jealous. What you do to the bottom, you have to do to the top. So that one also has to get multiplied by 3. Our new fraction is now 3/6. Okay, this 3. How do I make this 3 into a 6? 3 times what would give me 6? Justice? 3 times 2. So 3 times 2 to give me that new denominator of 6. But jealous sibling, what you do to the bottom, you have to do the top. So this 2 was jealous. It also gets to get multiplied by 2. 2 times 2 is 4. Now look at our new fractions that they have. 3/6 plus 4/6. Do we have like denominators now? Yes. So you could add them. 4 plus 3 is 7. Our denominator stays the same, and it's a 6. But we have to remember to reduce or simplify. Okay? And when you simplify this, you're going to get 1 and 1/6. Because 7/6, what kind of fraction is that called when my numerator is bigger than my denominator? Max, what's that called? improper fraction, and we cannot leave that an improper fraction. So when I subtract here, I have a denominator of 6. Well, I'm going to take that 6 and make it a whole number and show I've got one whole number with 1 left over becoming my numerator. All right, ladies and gentlemen, I know this was a lot, but we're going to practice. Save this anchor chart. It is on Schoology. You are going to need it to do your homework, okay? Lights, please. And let's start practicing. Lights on. Both on, please. Sorry. Go ahead. All right. Number 1. Number 1 in your math notebook. All right, here we go. I always want to check my denominators, right? Do I have like denominators? No. No, so I cannot add right now, okay? They are different numbers. I have to fix that. So, my first step then when you look up here is I need to make a list of my what? My multiples. So I have 9 and I have 3, okay? So let's go ahead and say our multiples of 9. Ready? 9, 18, 27. Let's stop there for now and let's see how many, and let's see if we need to keep going. Remember, we don't want to make a huge list here and make more work for ourselves than we need to. Let's just do a couple, 3 or 4 at a time. All right, multiples of 3. 3, 6, 9. Oop. Did we see one already? Yes. What is my LCM? 9. Circle it then. 9. 9 is my LCM that I'm going to be using. So if my LCM here is 9, that means I'm going to want to change both my denominators to what number? 9. Hold on. If I'm changing them both to 9, but look at this one. Do I need to change anything on that one? No. It already is. It what? 9. Wow, we love when that happens. That one's already a 9, so I can leave it alone. However, is this one a 9? No. No, so this one I do need to change. Okay? We're going to use some multiplication here. So 3 times what number would give me 9? 3. 3. Very nice. I'm going to use a different color. I want to be able to show you guys. Now, jealous sibling here. This 2 is jealous. What you do the bottom, then you also have to do the top. So it also gets multiplied by what? 3. So my new fraction here is what? 6. Not just 6, but 6 ninths. Okay? So I need to rewrite it down here. Now, do I have like denominators? Yes. Yes. I know in our anchor chart that we saw, they talked about writing them vertically. I don't always do that for my fractions though. So I'm going to leave that up to you. If you like your fraction reading across, or if you want to rewrite it 2 ninths plus 6 ninths. Okay? For my fractions, I actually usually leave them across. But either is going to be acceptable. It's going to be which view you like better. All right, so let's add here. I add my numerators. 2 plus 6 is? 8. And my denominator stays the? Same. It stays a 9. All right, at the end though, I got my answer. I always need to check to do what? Simplify. Can I simplify this fraction at all?
Yes. No. Wait, no.
No, there's nothing I could divide them both by. So this is your final answer here. Ladies and gentlemen, this was a lot, wasn't it? Yeah. I know it is. Okay? I only give you 10 problems on your homework because there are lots of steps, and I expect you to take your time and do them correctly. Okay? All right, let's go on. Number 2. All right, let's check. Do I have like denominators? No, so I know I'm going to have to change those denominators, right?
Yes.
All right, so I need to make a list of what?
Your
List of multiples. So I have 8 and 6. 8 and 6 because those are my 2 denominators. All right, multiples of 8. Ready? 8, 16, 24. Let's stop there. 6, 6, 12, 18. Do we have an LCM?
Yes.
Yes. What is it?
24.
Circle it. So I know that LCM, that's actually going to become my new what? Denominators. Yep. Those are becoming my denominators. Are either 124 yet? No. So I'm going to have to change both of these, right?
Yes.
All right. So to get an 8 to a 24, well, 8 times what number is 24? 8 times 3. Remember, jealous sibling, though, what you do to the bottom, you have to do to the top. So we also multiply 5 times.
3.
So let's rewrite that fraction. I now have what as a numerator
15.
and what as a denominator?
24.
Good. I also need now this 6 to become a 24. I can't just say I'm making a 24 without doing some steps. 6 times what is 24? Everybody?
4.
6 times 4. Jealous sibling, this one is jealous. What you do to the bottom, you have to do to the
Top.
So I'm also multiplying by
4.
my new fraction here then is, what's my numerator?
4.
My denominator?
24.
Good. Do I have like denominators now?
Yes.
Yes. Could I add them now?
Yes.
Yes. What is 15 plus 4?
19.
19. My denominator, do I change it? No. Can I simplify that at all?
Yes.
No. There's nothing I could divide those by. All right. Let's do number 3. Number 3, I'm going to have you try on your own. Ladies and gentlemen, your notebook needs to stay organized here. There are lots of steps that you're going to make a mistake on if you have sloppy work, not using your lines. I want you to try number 3 on your own. Okay? If you need to, look at our steps in number 2 to help you out. You try number 3. Step 1, check if those are like denominators. If not, you need to make a list of multiples. I want you to show your answer to a neighbor in your area. Raise your hand if you're still working. Okay, lots of friends still working. Keep going, guys. That's okay. I know it takes you a while, and there's nothing wrong with it taking you a while. You're taking your time. You're going through your steps. As long as you're being thorough, that is good. But just sitting there is not an option, okay? Raise your hand if you're still working. All right, go ahead and show your answer to a neighbor now. See if you guys agree or disagree. Discuss if you need to. If you guys got different answers, discuss your steps that you went through.
That's what I was getting.
Do you have yours?
I haven't finished, but that's what I was getting to.
Then right now you should keep going instead of just sitting. All right, let's check it. Do I have like denominators? No. So I need to make a list of multiples so I can change those denominators. Multiples of 20, ready?
20, 40, 60.
All right, good. Multiples of 5.
5, 15, 20.
What was my LCM?
20.
20. Circle it. All right, this one. What is that one already?
20.
Do I need to change that fraction at all then? No, that is wonderful when it has that, when one is already done for us. However, is this denominator 20? No, so I do need to change this one. 5 times what number is going to give me 20?
4.
Malia?
4.
Good. 5 times 4 is 20. Jealous sibling, this 2 is jealous of that 5. What I do to the bottom, I also have to do to the top. So I also have to multiply by 4. 2 times 4 is
8.
so my new fraction here is
8 20ths.
8 20ths. Now, do I have like denominators?
Yes.
Yes, and I did hear somebody say, oh, but you can simplify that. Do not simplify until the end. Okay, wait to the end and then we will simplify. All right, can I add my numerators now?
Yes.
What is 8 plus 3?
11.
My denominator is
20.
20. Can I simplify that?
No.
No. Had you simplified 8 20ths though, it would have changed that denominator. Okay, that's why we cannot simplify until the very end. And on this one, we could not. It was done. Very nice. All right.